conditionals and shapes. So I'm excited. So this will be a programming lecture today. We're finally going to learn how to do if, like check for stuff. It's going to make for much better programs, I think. So let's start with that. It's like, what is the equivalent in Python of your if then else kind of block thing? Let me fix my pens because nothing is correct today. There we go. So what is the equivalent of this in Python land? So like, kind of looked like an E, didn't it? Boop. So it was in Scratch, it was like this. If something pointy, yeah. Then we did the then part, right? If the pointy thing was true. And then if it wasn't true, if it was false, if your condition was false, it went and did the else pit, right? This is like otherwise, if that wasn't true, do this one. Okay, so how do we get all this in Python? That's where we're going. All right, that's useful. So to get there, we need to talk about true and false. So that's not a part of anything that we know so far. We know that like ints are whole numbers, floats are numbers with decimal places, strings, like you can write out a long sentence, sure. We have no way to represent true and false right now in Python. We need a new type for that. That's called the bool type. It's a very, very easy small type. It's a very small cloud. So just like int holds whole numbers 0, 42, negative 42. The bool type holds on to the type of things that are bools are just trues and falses. So it's capital true and capital false in Python. That's what it cares about. So yeah, we can hook into those trues and falses now that we know what type they're in. Okay, just like in Scratch, we can use true or false to control how the program works. Okay, so let's say we have some number that we get from the user, like n or something. They type it in, and we have the ability now. Once we can create booleans, bool variables, we can do one thing if your answer is true and potentially something different if it's false. Okay, so here's the goal. Like if n is 5, for example, we'll be able to ask these kinds of questions like, hey, is n less than 7, question mark. And if the answer is yes, then we can do something. Or if the answer is no, we can do something else. So that's the kind of thing in Boolean land. It's yes, that will give us back true, and we can use the true. All right, that's the kind of thing. Likewise, you can ask the question to Python, hey, is n like less than 3? And the answer is no, and the equivalent of no inside of a computer is false. Right? And then you can use the false to drive something, like come into your code, be like, hey, is n less than 7? If it's true, do one thing. If it's false, do something completely different. And that is where we're going. So that's beautiful. Okay, so booleans, bool, allows our execution to branch by having trues and falses. Okay, so the easiest way to make a bool is to just hard code it. Just be like, hey, bool b variable equals true. And then that legitimately makes a box that holds true. That's fine. I guess that works. So let me at least show you that right now, and we'll get to some larger things in just a second. So let's see here. Let's open up idle. Slowly but surely, and I'll make a new file for this part. I'll make this smaller if I can. So there's the REPL. I don't want to work in the REPL. I want to make a new file for myself. And I'll save this file somewhere that we'll be able to see it later. So let's go to this, and I'll make a folder for today. We are apparently lecture number 17. So let's make a folder for lecture 17. At least I will. And then I'll make this file called, I guess I'll call it bools.py. Right, so the easiest way to make a bool is to just like type out true or false. And that is legitimately a bool, and you can use it. Like print, what's the type of true? It's that new thing. It is now a bool. It's a new type that we have accessible to us now. So let's, I'll run that just to show you that it exists. It's like, yeah, that's a bool. Sure. It's happy. Type where all these things on the same page. And then you can ask it like, hey, we can make a variable, just like I was doing in the bottom there. B equals true. And now B is a bool, and like it holds on to what it's remembering. So you can save it that way. And you can also like check stuff. You can also check stuff like conditions. Those create booleans, right? Checking if something's less than 7. That's something you can do in Python land. You can just say, hey, how do I want to do this? Just be like, print the result of asking, hey, is 3 less than 2? That's not true, right? So it'll print false. This will result in false and print that answer out. So that's just those kinds of operations, those comparisons. Those are things you can do in Python to check things. And like, if you do it the other way in the REPL, is 2 less than 3? It's like that result is true. Okay? So that's how you can obtain true and false with more interesting operations. Does that make enough sense? So bool is a new type. It's got we need the ability to talk about true and false. We needed a type for that. We have not had it yet. Okay? And so that's going to give us branching eventually. Let's do fancier Boolean things. So Boolean expressions result in true or false. That's it's just code that results in a true or false. That's called a Boolean expression. It results in a bool. And so you can ask for like, you can do your comparisons, greater than, less than, stuff like that. So that's a thing. So if you had variables, for example, like if you had x holding 10 and y holding 5, you could ask Python, hey, is x greater than y? And it would result in true. And I can, let's see, I can prove that to you on the REPL. So, let's see, yeah. It's like if I made a variable x holding 10, and I made a variable y holding 5. Is x greater than y? Yes, true. Is y less than x? Also true. Is x less than y? False. So there's just a bunch of questions that you can ask Python. And if you want like less than or equal to, greater than or equal to, you just put an equal sign after, because that's hard to type. So is like, is 2 less than 2? No, but 2 is less than or equal to 2. You just put the equal sign right after it there. Okay, so that's how you find that and do that one. You also have checks for equality. A check for equality is a double equals, because you know that the single equals was like assigned to a variable that's already taken. So like you got to use 2 equalses to check for equality. So like is 2 equal to 2? Yes, it is. And then this exclamation point equals checks for disequality. That's the equivalent, because it's hard to type this on a keyboard, right? That's the equivalent of the not equals to sign. So you read the exclamation point as not. So that's not equals to check. Is it true that 2 is not equal to 3? Yes. Yes, it is. What about 2 not equal to 2? That's false. It is equal. You see that? So that's, well, those are those. Let's see. And yeah, then you can combine things, right? You can still combine things with your logical operators that you know and love from scratch, from just logic lectures. So and or not, if you spell them out, you get those things. So like you can check, hey, is like if you're going to make a program for an amusement park ride or something, check if somebody can go on the ride. Hey, is their age greater than 12? And is their height also? You just spell it out. And is it also true that their height is greater than or equal to 48 inches, stuff like that. And so you can use these combinators, you just spell them out. So remember what and does, it checks and makes sure they're both true. So like if you had x, you had y, x anded with y. Remember that truth table? If they're both true, then it is true, the and is true. But if there's any other combination with a false anywhere at all, false, false, then the and is false for the whole thing. Okay? So yeah, those all exist. And this is a way, these ands, ors, and nots, these are ways of taking, at least for and or, taking 2 booleans and making a third one, right, based on it. Not just takes one thing. So let's see. How do I want to do that? It's like print, hey, is it true that, what about print not B, negate B and print it out. So if B is true, not B is false, and so that'll print false there. See that? There's the false. And then remember the second equals when you're checking for equality. Watch out, you're going to mess up like this. It's not going to work out very well for you that time, but we all do this mistake. Watch out for that double equal compared to the single equal. The first one, this is checking for equality, gives back true or false. This one, single equals, sets a variable to a value. And I hate that. They should have made this equal sign like an arrow or something, but we have to live with it. So double equals for checking for equality. So is 3 equal to 3? That will be a yes answer, so it'll be true. Is 3 not equal to 3? The answer is no, so it'll give back false. I should say true, false. There it is, true, false. Okay? Any questions about those operators? Python will just check it for you, and if the answer is yes, it'll give back true. If the answer is no, it'll give back false. Okay? So, with that in mind, let me, I don't know where I want to do this, but let me give you a question. So here's some numbers that you care about, and let's say that you have a variable x, maybe you got it from the user, and you want to make sure that the user gave you a good value of that variable x, and you want to make sure it's one of these blue numbers. So these are the only numbers x should be. You want to make sure it's one of those, 4 through 8 or 13 through 15, all right? And I claim that you want to be able to check that, and here's one way. One of these options is the right way to check if x is one of the blue numbers. The rest are wrong in some way, right? So which of these comparisons, a bunch of things combined, right? Which of those comparisons is true when x is a blue thing and false any other time? So if x is like 4, it should be true. If x is like 10, it should be false, right? Which comparison will give back true only when x is a blue number and false every other time, right? So you can give that a try. And enter in your answer, please, on the by clicker page. And make sure to do attendance. I'll stop that after this question, if I remember. So yeah, help each other. See which of these comparisons will give you true only when x is blue. Your expert set. Hands and orbs. Or gives you. Which one's like more restrictive? Which one's more liberal? That might be helpful to think about it that way. You do have Python in front of you. You can make an x variable, try some values. Run it to convince yourself that your answer is right. Alright, 15 more seconds or so to get in your answer, or your best guess. Once you see the trick, you'll always be able to get this right. Alright. Let's take a look and see what we're thinking. Please click an answer. What are you thinking about? I think there's more than 6 of us in this room. Definitely ask questions next time. So, alright. We're thinking, those of us who responded, D, sadly, one of us thought that it was E. Maybe that is secret. That's the secret answer. It is E. Nice. So, let's figure out which one. Let's figure out which one. I promise to stop that too. It is going to be D, so good. Those of you who were confident. D is the answer, but let's talk about why the other ones don't work. Alright? So, this is saying A. Let's look at A. X is, like, it's true when X is greater than or equal to 4. So, like, this part of this condition is true when X is greater than or equal to 4. So, from, like, right here onwards, it'll make it all true. You see that? And then this and is kind of like reining it in on the other side. It's like, and also X is less than or equal to 15. See that? So that'll, like, pick out this bit and get all of these. And so the and is, like, hitting all this. You see how it's hitting some numbers that we didn't want to hit? It's got too many options. It'll be true when X is 9. Do you see that problem? So that's not good enough. So that's why A is not going to work. Let's look at B. So yeah, or, you're going to need an or to, like, section off pieces now. Now it's going to make a little bit more sense. So alright, this is true when X is strictly greater than 4. So we're missing the 4, sadly. And X is less than 8, strictly less than 8, so we're missing the 8. That's that bit. And then it's like that or this. So X is strictly greater than 13, strictly smaller than 15. So it's only picking out 5, 6, 7, and 14. See, that's what B is doing. Does that make sense how I'm reading that? That's important to understand. So it's not hitting enough numbers this time. So let's look at C. X is greater than or equal to 4. So it's going to hit 4 and go that way. And strictly smaller than 8. So it's going to rein it in and miss the 8, sadly. So that won't work. But we're almost there. And then also greater than 12 and less than 16. Or this is true. Greater than 12, so that hits 13 onwards. Less than 16 is 15 down. So this one's just missing the 8. Okay, so it's almost there. This is going to, like, by process of elimination, the answer is then D. But let's see why. X is strictly greater than 3, so from 3 onwards, and less than or equal to 8. So that's this bit. So that's picking out that range for now. And then we're like, or this allows us to have a new chunk somewhere else, or it'll be true if X is greater than or equal to 13. So that's from 13 onwards, and strictly smaller than 16, so that's from 15 down. Does that make sense how I'm explaining that? You see why the answer is going to be D? So that's how you check those things. Okay, so let's see here. Do I want to show you anything before I go to the next slide? I don't think so. So, let me show you how to use these trues and falses now. It's not an if block anymore, it's called an if statement in Python, right? That's going to test a condition, and if it's true, it'll run the code. There's also like an if else. I'm just going to show you the if only right now. So an if statement looks like this in Python. You say if, and then you put your condition, you put your Boolean expression right here that results in either true or false. So there you put a condition, then you put a colon, all right? And because you can't, like, click and drag things inside of something in Python, you have to indent. So you're going to tab over, and idle will do this for you. You have to, like, tab over or press space a few times to get in here. And then all of your indented lines become part of the body of that if, we say, right? So you put all the things indented. That's the code you want to run when the condition is true. Code to execute when cond is true. And then you just unindent when you're done with the body of the if, and you just want to go back to code that always runs. So at the top level, now you're back here, you're out of the if. So regardless of whether it was true or not, all this code down here will run now. Regular code here, that's always executed, just like any other piece of Python. That we know already. All right, so yeah, this is an if statement, only an if statement. It will run this code if the condition is true. If it's false, it skips over it. It just goes down to this immediately. All right, so after the indented code is finished, or if the condition is false, the program just keeps on continuing with the unindented code down there, just further down. Okay, so that's an if statement. Let me show that to you. I'll make a new file in idle called, I think I'll call it conditionals.py. I wish the window wasn't so large when I make it, but here it is. Let's get something looking like that. So let's set a variable. Say x equals 7, right? And then, I know, how about x equals like 15? And then I'll like have a test. Like if x is greater than 10, and it is right now, yeah, I'm gonna like indent. Idle does it for me, and I'm going to do stuff when x is 10. This is all the code that's gonna run only when x is greater than 10. So print like x is greater than 10. You can have other code in here and be like x equals x plus 1, print x, whatever you like. That's all there and possible. Okay? And then once you're done with stuff you only want to run if x is greater than 10, you'll unindent. Go back to the outermost layer, and this is just code that's always going to happen. This line always gets executed, no matter what. You can have as much just normal code as you need down here. All right, so this code, let's watch it work. It's going to, well, x is 15, so this is true, and because it's true, it runs all this code. It runs the body of the if, we say. So it's going to print all those things, make x 16, print that, and then it's done with the whole thing, and now it just jumps down to the rest of the code and runs it as usual. This line always gets executed for. So let me show you if it's false. So if I say x is 7, instead, now it's not greater than 10, right? So that's a false statement. This is false, so it'll skip over all this. And so it's just going to go straight to this stuff down here. All right? So only if it's true does it run the indented stuff. Any questions about that? Does that make sense? That's just a normal if. And then let's do the if then else that you remember from scratch. That's called an if else statement in Python. So same words, not too hard to remember. So because sometimes you want to do something when it's true and then another something when it's false. So this is the equivalent. I want to test my condition, and if it's true, I want to go one way. If it's false, I want to go a different way. And I'll put like true stuff. Got some code I want to run when it's true. And I got some false stuff. Some code I want to run when it's false. And this is what if else gives you. And then of course, you can go back, unindent once the whole thing's over, and go back to your straight line looking code that goes on forever. Okay? So yeah, this is how an if else statement works in Python. You say if, as usual, at the beginning, you say your condition. And then you put a colon again, so it's very similar to an if, normal if, without the else. And then you tab over, and you put all your true stuff, as many lines as you need. True stuff. And that's a capital T, true stuff. And then you unindent, and you say else, once you're done with your true stuff. Then you say else colon, and then you indent again, and you give your false stuff. That's how that works. So if your condition is true, indent it, runs all the indented things over here. Otherwise, if that's not true, it'll run all your indented false stuff in the else part. Okay? Let me show that to you. Let's section off the program. And let's do it differently. Let's use y instead of x now. Let's be like y equals 15. And I'll say if y is greater than 10, do stuff, whatever I want. Print y is greater than 10. Sure. And now I can have an else as well. Say else colon. I can put as many lines as I want down here too. And this will run when that's false. Y is not greater than 10 when we get to here, right? And then once you're done with both of them, it's like either one or the other is going to run. You can unindent, and just like once the whole thing's done, either one side or the other, just the rest of the unindented code will keep getting run. Always executed. Okay. Right? So this, when y is 15, like this is a true statement, so it's going to hit this body. It's going to run this one. Y is greater than 10. It's going to skip over this else. And it'll run this one. So let me run that with F5. So we see those two things. Y is greater than 10, always execute. If I make y not greater than 10, like I'll make it 9, or I can make it exactly 10 even, and run that, this is now a false statement, right? Y greater than 10, that's a false statement. So it hits the else instead of the if part, and it runs these lines, just the one. Y is not greater than 10, and then it's done with the whole thing at that point. It's like pick the side, now it's done with the whole thing, and it just like comes down to the rest of the code, right? So that's why we see that output with that value of y. Are there any questions about that one? So it's just very similar to Scratch. The way that you put stuff inside of stuff is that you indent in Python, which makes some logical sense, I hope. All right. If we're good with that, I have one last one to show you. There's like a combo of if and else at the same time, because one day you're going to need this. I want to talk about if, elif, else. That's the third thing. Elif. It's a weird word. It's short for else if at the same time, right? So one day you're going to have like messy bunches of conditions, and you need like a bunch of if-else's. It's going to get really disgusting. So for example, let's say you want to make like you're building Canvas or something. You're working on the next version of Canvas, and like Canvas gives you a letter grade based on your percentage. Like that's baked into the thing. So somebody programmed that, and here's how. So let's pretend we live in a world where there's only A's, C's, and F's, just to make it easy on ourselves. Let's just say that like if your grade is greater than or equal to 90, you get an A. Otherwise, if it's greater than or equal to 70, you get a C, like there's no B in between. And then otherwise, if none of that's true, then you get an F. Let's pretend we live in a world with easy grades like that. What do you have to do, like to print, like given a grade variable, print A, C, or F? Well, this is the kind of thing you have to translate to code. Let me draw just like a little flow chart first. It's like you got to check, is the grade greater than or equal to 90? If that's true, then you say that the grade is an A and call it a day. Otherwise, if that's false, you're not sure yet, right? You're not sure if it's a C or an F. So you have to like include another condition at that point. It's like, all right, let's check if it's greater than or equal to 70. Well, it wasn't greater than or equal to 90. Maybe it's greater than or equal to 70. And so again, you have the choice of either that being true or that being false. If that's true, then it's a C, right? Because you knew it was not an A because you would have gone that way. You went to here, it wasn't an A. So you know it could have been a C though. And so if that's true, it's a C for sure. And then otherwise, it wasn't greater than or equal to 90, it wasn't greater than or equal to 70, then it's for sure an F. So that's the kind of thing you have to translate into Python. And let me show you how to do that. Let's do that with what we know right now. I'll make a new file. I'll call this elif, because that's the cool new feature I want to show you eventually. So let's code this up. I know how to do this with just ifs and else's, right? It's going to look a little weird though. So let's get a grade from the user. Grade equals, let's ask the user for an input. Enter your grade, colon space. And then I want to do math with that input. So I want to, right now it's a string. I want to convert it to maybe a float, because like decimals would be included usually in a percentage for somebody's grade. And so now I have grade as a number. Let's do this. Let's print out. Let's do exactly this in code. So it's going to be the first thing we have to do is have an if. We got to check. Is it greater than or equal to 90? If grade is greater than or equal to 90, or 90.0 if you want to be very precise. Either one works. If that's true, it's an A. So we'll like print A. Yeah. And then otherwise, right, else. Now like we're here. Now we're here. We're in all this over here. We don't know if it's a C or an F. Like if we get here, it could be a C, or it could be an F. Right? We're not sure. So again, we have to have another check. So inside of this else, we need another if else. See that? So now we'll check, is it greater than or equal to 70? If grade is greater than or equal to 70.0, then I'll print, all right, if that's true, then it's a C, because I came around in a weird way, right? I know if I ever got to here, it wasn't greater than or equal to 90, so it's strictly smaller than 90. And then I'll check if it's greater than or equal to 70, that'll mean it's a C. See that? And then otherwise, else, if that's not true, so like I knew it wasn't greater than or equal to 90, then I also know if I got to this else, it wasn't greater than or equal to 70 if I ever got to here. And so that means it must have been an F. See that? You see how this code translates exactly this flowchart diagram? It looks a little weird though, like yeah, you got an if else within an if else. It's a little ugly, maybe. Let's ask the user for a grade. It'll be like, my grade's 95. Hit enter. Like it hits this one and then it's an A. And then of course, because that side was the true side, it skips over this whole thing, right? The whole thing's done at that point. So it goes and prints only A. Likewise, if I say my grade was 75, it'll be like, all right, check for, hey, is 75 greater than or equal to 90? No. So it's going to run this, the body of the else, and then it has another if else. So now it'll check this. Is grade greater than or equal to 70? Yes, it is. So it prints the C. So it runs this part, and it skips over that else, because it's always one or the other. Okay? And then one last one. Let's be like, our grade is 55, unfortunately. So we'll do, that'll print F, because this is not true, so it runs this. So it tries, now it moves on to this if else. Then it'll check this condition, and again, the answer is no, it's false. So it'll run this body. It's like, that's your otherwise. See that? So it'll only print F in that case. Any questions about this code? Does it make enough sense? I claim this could be cleaner, and there's a way. It's called elif. Makes it a little bit nicer. So instead of having to indent, you can use elif. It's short for else if. I don't like the underlines. It's not going to go away, sadly. Never mind. Elif is short for else if, and it's like a combination of the two. Else and if at the same time. So here's if elif else statements. You start it like this. You start it with if always, and then you put your first condition. Like I'll call this cond 1. Then you put a colon, and then you indent, and you have like your body of this if that's true, do this. Okay? And then otherwise, maybe like if this isn't true, you want to check something else. You know how to do it the other way, like you could indent, do weird things like this, or you could use elif. Read elif as otherwise. All right? Elif, you can put another condition now. Cond 2 maybe. Another colon. Body 2. And that'll check that condition if this first one was false. Or like, try this one now. And you can have as much elifs as you need. Like elif all the way down, millions of elifs. Some other condition K is true. Like you got a bunch of them. Then you have body number K. Okay, that's the idea. And then finally, you can have one last else. If none of that's true, body K plus 1. All right. So the way that this executes is you read elif as otherwise, and it just runs. It's only going to ever run one of these bodies. It's always going to run only one of the bodies, the first one that works. All right. So you read it like this. If the condition 1 is true, do the body 1, then you're done with the whole big long if elif a million times else. If that's true, you do body 1, call it a day. So otherwise, if that wasn't true, otherwise, maybe the condition 2 is true. If so, then you run body 2, call it a day. Again, you're done the first time you find something that works. So cond 2 only ever gets checked. Only ever tried if cond 1 fails, which means it's false. So you're only going to find the first one that works. All right, you're going to stop. And then you try them all. Maybe cond 2 is false, you try all of them. Maybe you try cond K. If that's true, you run this body, you're done with everything at that point. Just find the first one that works. If this one fails, this last one fails, then you finally roll over to the else. So this is only ever run the else body if every single condition above fails. Only if every cond is false. All right, so that's elif. You read it as otherwise, and it will save you some indentation. So instead of this, alternatively, here's what you could do. So alternatively, using if elif else, I'll take all this, copy it. Oops, go back there. So this one's fine. If grade is greater than or equal to 90, do that. And then you kind of can see how it's going to transform. Otherwise, if that's not true, maybe it was greater than or equal to 70. I can unindent a lot of stuff. If that's true, print C. Otherwise, none of that's true, print F. So these are equivalent. All right? So it's like first check this. If it's true, do that. Otherwise, oh, sorry, not else if, elif. Excuse me, sorry. Elif, grade is greater than or equal to 70, print C. Otherwise, if none of that's true, print F. It's only one or the other. And this one might make a lot more sense to you right now because you know like what if does, what else does, but I believe that you'll grow to prefer this way with larger bits of conditions. So if I enter like 95 again, these are all going to correspond. They're equivalent pieces of code. They're both going to say A. They're both going to say C if I do 75. They're both going to say F if I do 55. Are there any questions about that correspondence? It's a cool little idea. Pretty useful. Let's see here. Yeah, if we're good, I want to switch gears to Turtle Land, if that's all right. So now you know how to condition on things. It's exciting. That's very, very powerful. So, yeah. Let's move on. Let's talk about how to draw cool stuff. Let's draw with colors and shapes. Okay? So I'm very excited. So, because by default in Turtle Land, you got only like black. Default color was black. That maybe wasn't cool. You can have, and we can confirm this when the in the documentation page, Python Turtle. It's turtle.pen color. That's like the color on his tail. So color control, you got a bunch of these. I'll talk about fill color later. But pen color, turtle.pen color, you give it a string that represents the color you'd like pen color brown. I don't know why they wanted that, but you can make pen color red, pen color blue, right? And that will take the turtle and draw different colored lines. Like here's a little turtle. If you say turtle.pen color red, then like he starts dipping his tail in red ink, and then you can make marks with it. Then you can go a little bit, and then you can change the pen color to something else. You can be like pen color blue now, and then you can go forward from there. And so you can make some really cool, weird looking stuff like that. Okay, so that's that. Let me show that to you, just for fun, and then we can have more fun with that later. But I'll make a new file, and I'll save it as coloredlines.py. So you have that for yourself later. That's a default window size, man, so large. Here's the idea. So let's import the turtle library, of course, so we can use the turtle. And then we'll be like, I always like my turtle to look like a turtle, so turtle.shape turtle. And then remember that strings could be either double quotes or single quotes, so I can say turtle.pen color single quotes red. That's fine. And then he's ready to draw red marks. And actually, the turtle changes color, and you can see what he's about to draw. I don't know if you can see right now, but he's outlined in red right now. Like that's how you can keep track of like what he's going to draw. So that's pretty helpful, I think. So yeah, pen color red. You can make some marks. Turtle dot forward. I don't want to do anything too exciting. Forward 100. Turtle dot left 90. And then maybe I'll change the color to blue and go forward some more. So I'll just turn a corner, draw a different corner in blue. See that? So this code corresponds to that, and now I've made some colored marks. Isn't that really cool? So it's just turtle.pen color. You give a string with the color in it, and most colors are accepted. It knows all the colors of the rainbow at least. It's lowercase though. For those, any questions about that? Just another library function, very helpful for us. I think the cooler thing that I want to show you is how to fill in your shapes with colors. So like you're making lines, you make shapes. Let me show you how to fill in those shapes. It's really, really nice. So like you can draw a square. We know how to draw a square. I'll tell the turtle to do all that. Once the turtle's done, if you do it right, there's a way to tell him to fill in that thing that you just drew and closed off with a certain color. And that's called the fill color. Turtle.fill color sets the fill color of the turtle. And here is how that works. It's should be above here somewhere. Fill color. Just say turtle.fill color. And then you draw something in a special way. Alright, here's the secret. So this will set the fill color, but the turtle does not know when you want something filled. You have to tell him. Alright? So you have to wrap around, like if you draw a square, for example, you have to wrap around your square drawing code with these two things. You got to say turtle.beginFill to tell the turtle I'm ready to start filling in things, like fill in everything after I close up my shape. So get ready to start filling things, and then you draw your shape. Like you draw your shape, whatever it looks like, nice and cool. And then you say end fill, turtle.end fill, to remind him, like, all right, I'm done now, fill in what I just drew. And assuming you close it off correctly, he'll start filling in that shape that you drew, just between those calls to begin and end. All right? So you have to use begin fill and end fill in between every shape that you draw. All right? Now you can set the fill color. So let's do that. Let's do that. Let's tack on to this code. So I'll make a new file. I'll copy and paste all this. I'll make a new file and I'll call it filledshapes.py. So I'll get rid of that one. I'll paste in that code, so I still want that. So let's make a weird looking square with weird colors everywhere. So let's like have this turn left 90 again. Let's just make a normal square right now with red and blue. So it's just a bunch of these, right? 4 of them. So this is a weird looking square right now. Cool. Let's have it be filled with some other color. Let's make it green. Why not? So the way to do that is to say turtle.fillColor, and then you say green. Whatever color you want. You can change yours when you're trying it. But like before you start doing anything, you say turtle.fillColor, green, and that still doesn't set anything, but you can actually see the turtle changes colors. Like the outline of the turtle is the pen color, the fill of the turtle is the fill color, so it's a helpful reminder. And then what? So we got to do the begin fill and end fill now. All right. So in between me drawing my square, in between every shape, got to say, all right, I'm ready for you to start filling this once I'm done. So you got to say start filling, Mr. Turtle, please. So you say turtle.begin _ fill. Just call it. All right. And then once you're done drawing your square, you say, or whatever you wanted to draw, you say turtle.end fill after all that. And that just says, all right, you close it off, then he'll finally fill in what you just drew with that fill color. So if I run this, so he draws the square first, and then he fills it in. Look at that. So that is very cool, very powerful. Any questions about how to do that? It's just like you wrap around the shape that you draw and begin fill, end fill, making sure to set the fill color before you start. Or at least before the end fill, yeah.
What if on the very last blue line you were to set it to like 99?
What if it didn't close it off? That's a good question. Let's try that. It might do a best effort kind of filling, or it could give up. I could see either one happening. So yeah, he did it still, but this would look a little weird if you did weird polygons, I would say. So the turtle is being nice to you if you forget to completely close off your shapes, but it's better to close them off for sure. That's a good question. Any other questions? So yeah, I think you can imagine how cool this would be. You can make some cool abstract art now with just a bunch of weird looking squares all over the place. And how would you get a bunch of them? Well, you might need loops, or you can just copy and paste code. And how would you get like weird squares every time? You could use randomness. So there's a random library in Python, and I want to show that to you now. That's going to help us do cool things. So we're going to say import random, and there's a bunch of stuff in the random library. The one thing we're going to use today, the thing that we're going to use the most in this class, is the randint function. There are a bunch of other random functions that are useful, and you can look into them. We're going to say import random, and that gives us access to the random library. And we can use the turtle library and the random library together, which will be really nice. So scrolling down, random library, we're going to use random.randint. So you give two numbers, like a and b, and it gives you back a random number between a and b. So like you say randint 1, 100, it will give you back a random number between 1 and 100, and it will be different every time you run the program, which is really cool. So that's helpful when you're like going to draw stuff. And so like here is a random number between 1 and 10, and you can save that away to be used for something. Does that make sense? So that'll work like that, yeah.
Including the two numbers A and B, or
It's inclusive, yes. So 1 and 10 are options. It's less than or equal to and greater than or equal to. So it's within the range inclusive.
what if you do 10 and 1? Would you do it the same thing?
I don't, like, judging by this, like, I don't think it'll work. Seems like it's unhappy about that. But we can figure that out. Let's see here. Do I want to show you that? Let me just show this to you now, and then we can try that. Yeah, that's just another question of, is the library going to be nice to us or not? So let's, I'll make a new file. I'll call it randomness.py, and I'll import the random library, and I'll say what I said on the slide at least. I'll be like, n, I'll call random.randint between 1 and 10. That'll generate a random number between 1 and 10. We'll get it back. We should save it, and then we can use it. And so this line right here gives back a random number between 1 and 10. Then you can print out whichever one that was. Say print n if I run the program. And so this time it was 10, magically. If I rerun the program, it's a different number. Now it's 3. So it's different every time I run it. And I'm not sure what's going to happen if I do it backwards. That's incorrect according to the module. Oh, it actually gives you an error if you do it wrong like that. It's like that's not a valid range, which makes sense. That's pretty nice and helpful. So yeah, run it a bunch of times, you get a different number every time, and that's helpful. Like if you're making a video game, if you're trying to make art, it's different every time. That's very, very cool. So yeah, are we good with that? That's making that thing. We can print it out after we're done. We have it. And I think you see where I'm going with this. I was trying to hint at it. Let's make a bunch of random squares. That'll be so cool. So let's make a bunch of random squares of a random, of a random size and location. All right. So here's my canvas. It's got a bunch of coordinates. Let's draw a bunch of squares, like some over here, some over here, some over here. So like they could overlap each other. It's fine. Let's draw a bunch of random squares. And the way that we're going to do it is we're going to pick a starting point for our squares randomly. All right, we're going to pick a starting point randomly, and that'll be like, we'll call that like starting x and starting y. Randomly pick a coordinate there, starting y, randomly pick a coordinate there, and then we'll warp there with the go-to. Like maybe that starting x and starting y will represent the bottom left corner. Let's pretend it's going to represent the bottom left corner of our square. And then, so we'll like do something like this for starting x and starting y, random coordinates. And then we'll pick a random size for that square we're about to draw. Again, we can just pick a random number, like a random int between 50 and 200. Call that square side length. Side length. Long variable name, whatever that is. Maybe this is like negative 200. Maybe this is positive 100. And this is like 150 or something. And this is all you need to draw a square, right? If you think that this starting x and y is always going to be the bottom left corner, now you know the side length as well. You just like turn the turtle right, go forward by that side length, go turn left, turn left by 90, go forward by the side length again. Just keep doing that 4 times. Yeah, these are all the variables you need to represent a square. Then you can go off and go to there and start drawing a square of this particular size. Okay, does that make sense? And yeah, let's do that. Let's do that, and then we'll fill them in a second. We'll have fun with it. So let's see. I'll make a new file, of course, and I'll call it random squares. Dun, dun, dun. And yeah, and then for fun, maybe should I do this right now? Yeah, why not? Let's also ask the user, like we'll fill in the squares too. Let's ask the user for what color they want the square to be. So that'll be fun. So let's see. Let me Let me get a filled, this is almost a filled square. Let me go back to this code. It's helpful. So I'll call this, I'll paste that in. I'll call this random squares.py. Get all these out of here. So here's just the stuff that drew a single square filled in. Like the fill color was green. Let's start with this at least. And let's see. This just draws a square of a certain normal size, right? And it begins fill and ends fill. Yeah, so this is just like this code, all this chunk right here draws a square. I guess we don't need that last left 90 if we didn't want it. Just like go forward. So this draws a very particular square, right? It's just wherever the turtle was, like go forward 100. The side length is 100 for this particular square, right? And it's got some weird pen color stuff that we can get rid of. So I don't care about that right now. So this draws a square. This draws a filled square, and the fill color is green. Okay, so this is just the relevant minimal code to draw a square of side length 100 at least, a filled one. Side length 100. If I want a different side length, I can pick a random number. So let's import the random library for that. So I'll say in addition to import turtle, I'll say import random as well. And let's see. If I want a different side length, I have to change this 100 to something else, right? So I'm gonna say square side length equals a random number between 50 and 200. Does that make sense? So now I have a random side length to use, and I can just, instead of 100 everywhere, I'll just say go forward by that amount. And so that's going to draw at the origin still, so the turtle hasn't moved anywhere, starting at 0, 0 still. We'll fix that in a second. But do you see how that's going to change the size of that square? So like go forward by whatever that amount was, that random thing that was stored into that variable. Maybe it was 50, maybe it was 150. So sometimes we'll get like a bigger square. That's one way, so that's some side length. If I run it again, even bigger square. See how it was random? It's pretty nice. Even bigger square, apparently, that's possible. Medium-sized square. So it's different every time. See that? So go forward by whatever the square side length was. Does that make sense why it's going to be random and different? Yeah. By default, the turtle's line color is black, and so I didn't change it. Oh, it's turtle.pen color. Any other questions? I got way too many Python windows open. So yeah, now let's make this square in a weird spot. Let's be like starting x, starting y. Let's pick a random spot for that square to be. So I'll be like, all right, I'll put my random stuff all together. Starting x, go there, and then starting y can be also somewhere in between there. Starting x and starting y can be a random number between negative 200 and positive 200. So it'll be a square in a weird spot. And this will represent the bottom left corner of the square. Let's pretend that. All right. So the second I've chosen all these, like I have a square in my mind now. This is a random spot. So I need to go there. Right? If I want to make a square there, I have to go to that spot. I have to go to the random starting point. And also, if I'm going to draw a square starting from the bottom left, I want to then like face east, right? So I can go forward and then keep on turning. So I need to always make sure I'm going to face east when I get there. Go to the random starting point and face east. So I'm always in the right spot to make a square. So I'll say turtle.up to warp there, right? Turtle.goto now. I won't make any marks because the tail's up. Go to, I don't know what it was, but it's stored here. It's this random number stored here, starting x and starting y. Go to there, and then also face east. So one way to do that is to say turtle.set heading to 0 degrees, and apparently that's east by default, facing right. And then we can put the tail down. Now we're ready to make marks at that location. So do you see how this code all working together, fill color is still just green. This will pick a random starting bottom left corner for our turtle, and a random side length for the square drawn there. We're going to warp to that starting location. There we are. We're going to make sure to face east so that really was the bottom left corner. And then I'll draw the bottom side of that side length. Go forward, then I turn left 90, Then I'll draw the right side of the square, left 90, top part of the square, left 90, left side of the square. So whatever that random side length was, and it's going to be different every time. Whee, so there's a square over there of that size. Does that make sense? If I run it again, it's a square kind of in the middle of a similar kind of size, but it's random. A bigger square up there. It'll keep on changing. Isn't that nice? So now it's kind of hidden even. Any questions about why that code is drawn a random square? So let's ask the user for which color to use. So it doesn't have to be green every time. It'll be up to the user now. So instead of setting the fill color to green, let's set it to whatever we want the color to be from the user. So we'll ask the user first, like, hey, input, enter the color you'd like, and we'll use whatever that was. So we'll save that as a stir. It's all it needs to be as a stir. So I'll save that into a color to use variable. And then I'll set the fill color not to green, but whatever the user type. So whatever I shoved into the color to use variable. See how that'll make it different every time now? So if I run this, and I can say, I would like, in the REPL, enter the color, I'll say like red. I'd like my random square to be red this time. And then it'll be up there. Likewise, enter the color, I can say I want my random square to be blue. And so I picked a random side length, and there it was. Does that make enough sense to us? Any questions about that? I was going to pick a random spot for the turtle to begin. Random side length. These three variables represent some square somewhere. Then we can go there and draw that. It's been chosen for us at that point. Go to that spot, get ready. This is drawing the actual square. Then we're good to go. Alright, so I haven't shown you the equivalent of the repeats block yet. I haven't shown you how to loop and scratch. So if we want to draw 5 squares, which will look cool, 5 random squares in total, I just have to like copy and paste the code, sadly, 5 times. We'll fix that soon. But let me take the relevant code that draws a single random square. It's this code starting here, up here, all the way to this down here, right? If I repeat this 5 times, then I'll get 5 random squares, all of the same color from the user at the start there. So I'll paste it once, twice, 3 times, another time, and I think that's 5 total in theory. Let's confirm that. So I got 1 there, 2, 3, 4, 5. So it's doing all that same code, this exact code in between these number signs, these comments, 5 times. And so it's going to keep on resetting these variables to new different values, isn't it? New different values to start at some weird other place to draw another random square. So 5 total. Okay? After the user tells us what color they want us to use. So save that. If I run this, be like, enter the color red, and then it's going to draw 5 red random squares. It's going to pick 5 random starting left coordinates, starting up bottom left coordinates, and then random side length. So you get some cool looking abstract art now. It can be your new phone background. Enter the color pink. It's got a bunch of colors baked in. You can search for them. Those are all so cute, right? I think that's what I wanted to show you. I don't know, what's our favorite color? Orange. I haven't used that yet. And so, because I copied and pasted it 5 times, it's going to draw 5 random squares. Are there any questions why this code? I think you can imagine what it looks like. It's just a bunch of copy and pasted things. Why that's going to make the squares? Cool, huh? All right. So, yeah, this is nice. We have the ability to do some really cool stuff now with all this. And I'll give you this code, but that leads us very nicely into our next programming assignment. And I doubt you've seen it, but there used to be a really dumb YouTube video that had like some scary looking characters, and they like had a little song in it, like green was not a creative color, according to that video, if you remember it. So I'm going to give you a programming assignment similar to that silly video. Feel free to watch it. But it's going to have to do with that kind of thing I just did, making some random shapes. Okay? So instead of making a bunch of squares, I'm going to task you with making a bunch of random triangles. All right? So you're going to do something very similar to what I did. Take my code, modify it for sure. But you're going to make triangles, and you're going to ask the user for what color they want, but green is not a creative color apparently, so they cannot have it green. If the user asks for green, you must disobey them. So let me spell that out. All right, so I want you to write a Python program using turtle and random to draw 10 total triangles of a random size and random location. All right, you can just use equilateral triangles; those are the easiest ones to draw. That's fine. All right, so 10 triangles, random size, random location. That's the first requirement. Next requirement is your program, just like I did, you have to ask the user which color they'd like to use as the fill color. Okay? And then usually let that happen. And usually use that color to fill in your triangles. So set the fill color usually to that color with the following caveat. So this is me forcing you to use an if statement, right? So if the user asks you to fill in those triangles with green, don't let it be green. You must disobey them. So pick some other color, make them pink or something, or like re-ask if you'd like, if you know how to use loops already. But like, if the user asks for the fill color of green, I'm forcing you to use an if statement here. This is why. You have to disobey them. Like, make it pink, make it purple, something other than green. All right. In that case, does that make sense? So that's your total idea. So you can reuse a lot of my square drawing code, but that's what I want you to turn in. Give me a video of you explaining the code that does that. Are there any questions about that assignment? So you got a couple weeks. This is after spring break as well. So week 12 is after spring break. So you got technically 3 weeks to do it. You're welcome. But that is going to be your program. So you're going to draw 10 triangles of random size and location of a color of the user's choosing, as long as it's not green. If they ask you to draw that square or those triangles in green, disobey them, make it a different color. Does that make sense? So that's going to be your programming assignment, forcing you to use at least one if statement, practicing everything we learned. So yeah, that's now published, available for you to look at and use and get started on. And I think that was everything I wanted to talk about today. So yeah, the rest of the time is yours to work and ask questions, whatever you need to do.